Alright class, we're going to take a look at rational expressions now. And before we do that, we've got to figure out what it is that these expressions can't be in terms of x. In other words, we're going to take a look at their domains. Okay, and the domain is the the set of x's. Okay, now x can be any number for these equations except what makes the denominator, the bottom, equal to 0. And the reason why is because we can't divide by 0. If you divide by 0, so anything over 0 is undefined. So what we're saying is, well, we can't have this bottom equal to 0. So, and again, we're saying x can be any other number except for what would make the bottom, the denominator, equal to 0. So what you were supposed to do to figure out the domain is just ignore the top and just set the bottom equal to 0 and solve, and say you could put an equal sign or say can't equal 0 and solve from there. Either way, whichever way makes more sense for you. So if I leave the can't equal 0 because it can't be 0, I go ahead and add the 14 and we say 7x can't be 14 now, and then divide by 2. What we're saying is that divide by 7. I was jumping to the answer, that x cannot be 2. So if you divide by 7, again, you find that x can't be 2. In other words, if I put a 2 in to this original equation right here, that would give me 7 times 2, which is 14, minus 14. The answer would give me 3 over 0. Now, that's undefined, so that's no good. So we're saying that for this particular equation, everything works except that x cannot be 2. Because if it's 2, the denominator equals 0. Now in this next problem, we're going to look at the denominator. Is there any way we can make the 3 become 0? If you put equals 0, it doesn't really do anything for you because it's still 3. So that doesn't work for us. There's no variable on the bottom, whereas in the first problem there was an x value on the bottom. Because there's no variable on the bottom, there is no issue. So for this problem, we would say, if it asked for the domain, you would say all real numbers. Okay, because we only find issues when the variable is actually on the bottom, and we have to figure out what number, when I plug it in, would make the bottom equal 0. Well, in the second example, there is not a variable on the bottom, so there's nothing I can plug into the bottom to make it equal to 0. So there's no issues. I can plug anything into x and I have no problems for these particular example, or the second example. Now we're going to look at some more rational expressions. The directions here says write it in lowest terms. You might also see a problem like this that asks about the domain. So before we worry about the lowest terms, let's talk about the domain and further our discussion from the last slide. What I should do is, because there are variables on the bottom this time, I ignore the top. I don't care about the top at all. I just set the bottom equal to 0. And we learned from our last lesson how to solve these. I set each one now equal to 0 using the zero product property. So I'd say x plus 2 equals 0. And what I mean by equals 0, it can't equal 0. And then x minus 3 cannot equal 0. So I solve each one of these equations, and so x cannot be negative 2, and x cannot be 3. So that is our domain. Domain is all real numbers except that x can't be negative 2, and x can't be 3. Okay, so if it might ask for restrictions, or it might ask about the domain, and this would be that answer. Okay, so now that we've decided that, we want to take a look at back what they were asking us to do in the first place, which is to write this in lowest terms. What that means is cancel anything that you can actually cancel. And what we'll notice here is that there's an x plus 2 on the bottom that there's also on the top. So what we want to do is go ahead and cancel those out, because anything divided by itself is 1, and we're left with x plus 5 over x minus 3. And this is my answer, and I would still have to keep this x can equal negative 2 and negative 3. Again, the domain part you would have to do first and then do the canceling. Because if you didn't do the domain first, you might only have looked at x minus 3 and then said that, oh, x can't be positive 3. But this negative 2 was there in the beginning, and so we actually have to leave that as part of our domain answer, or domain description. Now we're going to take a look at a more complicated rational expression problem, where it still says write it in lowest terms. And so this time the difference between this problem and the last problem, of course, is that the last problem was factored, this one's not. So I actually have to go through and factor the top and the bottom using the magic x. So if I do the magic x on top, I would get negative 6, negative 1, and then that would give me negative 3 and 2. And if I divide both by a, the top's going to give me a minus 3 times a plus 2. And then I do the same thing on the bottom. Do the magic x, 6 on top, 5 on the bottom. This is going to be positive 3, positive 2. Divide both of those by a, and that gives me a plus 3 and a plus 2. Okay, so that's what they both turn into, so I could rewrite it. And then I know we're going to see that we can probably do some canceling here. But again, like I said on the last slide, before I do canceling, I actually need to think about my domain. So I need to actually think about if this bottom was, it can't be equal to 0. So I say, alright, it can't equal 0, so I set each one equal to 0 and solve. So a plus 3 can't be 0, and a plus 2 can't be 0. So that means I solve each one, I get a cannot be negative 3, and a cannot be negative 2. So that's part of my domain. I just kind of have to have that off to the side. And then I go back to my equation right here and simplify and put it in lowest terms. And putting it in lowest terms just simply means canceling out the part that can cancel. And you're left with a minus 3 over a plus 3. So I write a minus 3 over a plus 3. And I would say such that, that's just a colon right there, by the way, that a can't equal negative 3 and negative 2. Okay? So here's another example of rational expression that we need to put in lowest terms. And on this particular problem, there's just a different type of factoring that we have to do. On the top, I hope you can recognize that's difference of squares. So we're going to rewrite that to be y plus 4 and y minus 4. Okay? And on the bottom, it also can factor, but before I even factor it, I just need to think through. I can right now say, well, it can't be 0, and figure out what would make my domain have any issues. So I go ahead and solve for that y on the bottom, and I would do that by subtracting 4, and then I get 2y can't equal negative 4, and divide by 2, and I get y cannot equal negative 2. Because if y was negative 2, the bottom would become 0. So now I'm going to back up a little bit. Now that I figured out what the bottom can't be, I want to go ahead and factor it. So the bottom, I can factor out a 2. They have a GCF. So I make it 2y plus 2. And I'm just noticing at the top should have been y plus 2, y minus 2. I apologize. So if you got that a second ago, again, I just changed it to be y plus 2, y minus 2 because it factors using difference of squares. I put the 4. Sorry about that. And so now the 2y plus 4 replaces, it gets replaced by this 2y plus 2. And on the top, the y minus 4, y squared minus 4 gets replaced by its difference of squares factors. So I'm going to rewrite it to be y plus 2 times y minus 2. And on the bottom we have 2y plus 2. Okay. So now to put it in lowest terms, I want to go ahead and cancel my y plus 2's. Because they're the same terms, top and bottom, I can divide those. And what's resulting is a y minus 2 over 2. This is your lowest terms, and then of course we would say that y can't equal negative 2. Alright, now we're going to take a look at an even more complicated problem to put it into lowest terms. And now this time, if you look at the bottom, there's some things going on, and we can't exactly look at it right now and say what it can't be to make it equal 0. And so what we're going to do is factor the top and the bottom. Now when there's 4 things, the fourth method of factoring is factoring by grouping. And so what we need to do on the top and on the bottom is factor each one of them by grouping. And so what we do is we draw a line down the middle, and we look at these first two and say, do they have anything in common? And that gives, they both have an r, so we pull out an r and we have p plus q. And then we look at the second two and they both have an s in common, so I pull out an s and say p plus q again. And if you recall from grouping, at this step what we want to do is pull out the p plus q's, and what that will turn into is p plus q times what's left over, which was the r and the s. So r plus s. Okay? Now on the bottom, you factor it by grouping also. They both have an r in common, and left over is p plus q. And the second one has an s in common. In fact, there's a negative s in common, so we say minus s, and so we say p plus q is left. Okay? Now they both have a p plus q in common, so we rewrite it to say p plus q times the leftover, which is r minus s. Now in this particular problem, we're not going to worry about the domain, because there's not really one thing you could plug in to make the bottom 0. You'd have to have multiple variables equal to 0. So, but we can go ahead and cancel here. We've got p plus q on the top and p plus q on the bottom. They can cancel out. And your final answer is just r plus s over r minus s. So even though the problem looked really weird at the beginning, it's just two factoring by grouping problems, and then they have some nice canceling. Now I show this next example just to remind you that there are some nice problems, but when you see a problem like this, you've got to realize that there is not really anything you can do to put this in lower terms. Sometimes it happens where there's no factoring or any canceling that can be done. There's not even a variable on the bottom that we have to worry about. So it's just a plus 8 plus k over 16, and that is lowest terms. So it is possible that there are some problems that are already in lowest terms. Now I wanted to show this example, which is similar to the ones that I already did, but what happens sometimes is it looks like it's going to cancel. Like we might see that these x minus 6 and 6 minus x looks like they're supposed to cancel, or even these, like they're supposed to cancel. The x plus 5 and the 5 minus x. When you see a problem like this, it's possible that you can still have something cancel, it's just not yet. So what you have to do is look for any factoring of a negative that you could do to change the equation around. So, for example, this is a positive 6 and a negative x. If I was to change the signs there to make this one positive and that one negative, now that would turn into x, positive x, minus 6, and that's what I have on top. So that's what I want to have happen. Well, I can't just magically change the signs unless I pulled out a negative, or divided by a negative, or factored out a negative. If I do that and put the negative in front, then it's okay, I can change both the signs. Because if I was to work backwards and distribute the negative, it would turn it back into negative x plus 6, which is what I started with. Okay? So, on this example, what I'm going to do is rewrite that to be x minus 6 on top times x plus 5, and then on the bottom, like I was talking about, I'm going to factor out a negative and make it x minus 6. And then you're still left with your 5 minus x. Okay? Now, because you both on the top and bottom have x minus 6's, those can cancel, and you're left with x plus 5 over 5 minus x. Now, there's a negative sign on the bottom that we should probably distribute back in. You could technically leave it like that, but I don't know if the lab will accept that as an answer. I would be okay with that. But you can distribute it back in, and it would give you x plus 5 over, this should turn into positive x minus 5 if you rearranged it properly. Okay? Now, on this problem, I didn't talk about the domain. I don't think all of the problems on the lab ask about the domain, but going back, looking at the domain, if you were to do it, you should do it from the beginning each time if you were actually asked for it. On this one, you look at the 6 minus x and the 5 minus x and see what would make those 0. And so you would find that x can't be 6, and then x can't be 5. So that would be what the domain would be. But this is your actual answer over here, the x plus 5 over x minus 5. Okay? and then domain was a afterthought.